Okay, have a pleasant day today. Let's continue our study, air conditioning and ventilation system. Welcome again sa ating pag-aaral. Ngayon, aaralin po natin yung thermodynamic wet bulb temperature or adiabatic saturation temperature. So, let's say meron kang unsaturated air at point 1. Pumasok siya rito sa insulated container chamber na ito. So, ang condition niya is, siyempre, meron kang DP, meron kang specific enthalpy, 1 with a subscript 1, 1, nag-exit siya rito sa 2. Meron kang enthalpy din dyan, same property na siyang pumasok. So, may makeup air ka rito, makeup water ka rito sa itaas. So, ibig sabihin, nag-i-inject ka dyan ng water, makeup water ang tawag. So, minix mo yung unsaturated air. Kumbaga, nagdagdag ka ng water sa unsaturated air. So, ganun lang yung process. Ang tawag dyan, adiabatic saturation. Adiabatic saturation temperature. So, ginagamit itong system na to sa sa cooling tower. So, sabi rito, basahin natin, the thermodynamic wet bulb temperature or adiabatic saturation temperature is the temperature at which air can be brought to saturation state. Kasi yung air mo ay superheated. So, para baba mo madala mo siya doon sa saturation line, kailangan mo ng ganitong process, no? By evaporation of water into the air. So, ulitin ko lang. Thermodynamic wet bulb temperature or adiabatic saturation temperature is the temperature at which air can be brought to saturation state. Adiabatically by, evaporation pala. Ng water vapor into the flowing air. So, the equipment used for the adiabatic saturation of air in its simplest form contains of insulated chamber. Ito na, nabanggit ko. Insulated chamber to. Yan. Chamber yan eh. Water sa ibaba. May water ka na parang nag-spray from top doon sa roof sa taas. May hangin kang pumapasok dito at may lalabas ka doon sa point 2, ang entry niya point 1. Okay? So, there is also an arrangement for entry of water or arrangement for extra water known as makeup into the chamber from top. Ito na nga, may makeup ka. So, may water ka rito. May unsaturated air kang dadaan. Okay. Tapos, there is a process that will take place. So, let the unsaturated air enters the chamber at section 1. Ito, mahalaga maintindihan to. As the air passes through the chamber over long sheet of water, let the water evaporate. So, nag-evaporate daw tong water na to. So, nag-evaporate to. So, pag nag-evaporate siya, it carries with the flowing steam of air and specific humidity, air increases. The makeup water, itong water sa ibaba, is added to the chamber at this temperature to make up the water level. So yung system niya, hindi yung parang parang mag-spray ka ng water tapos magmi-mix yung unsaturated air with the water tapos ika-cuts dito sa basin na to. Hindi ganun. Aandar lang yung make-up water mo to make up the level. Kunyari, nabawasan na to, no? Itong water mo, yung water level, bumaba. Aandar tong make-up water mo from top para i-make up nga niya yung level na nawala. Halimbawa, ito, nandito na lang yung level. So, ipupunuin niya ulit to that level. So, yun lang yung yun yung kanyang purpose. So, hindi siya yung parang nandiyan dyan para sprayhan yung unsaturated air. Okay? Ang water natin, talagang nandito lang, dadaan lang yung init yung unsaturated air, then magkakaroon ng evaporation process. Okay, let's move on. So both the air and water are cooled as the evaporation take place. So cooled kasi nga nagkaroon to ng ng thermal equilibrium tawag natin dyan Yung higher energy na molecules, yun yung hot region. Nagmi-mix doon sa lower energy molecule. Tapos, they will attain the thermal equilibrium. Ibig sabihin, parehas na silang ng temperature. So, the process continues until energy, energy transferred from air to the water is equal to the energy required to evaporate water. When the steady condition are reached, the air flowing section 2 is saturated na siya with water vapor. The temperature of the saturated air in section 2 is known as thermodynamic wet bulb temperature or adiabatic temperature or adiabatic saturation temperature. Okay? So ito yung TS diagram niya. Okay, na-explain ko na rin ito before na ang initial condition mo unsaturated na sa superheated region. Ito. Constant corresponding to cooling. Pag kinul mo to, tuloy-tuloy, pupunta ka rito sa saturation line ito. Dew point of unsaturated area. Pero yung pinakita niya kanina, nandito sa point 2. From 1, superheated yung dry air mo or moist air kasi moist. May kasama water vapor. Nagkaroon sa ng adiabatic saturation process, bumaba siya yung kanyang temperature, yung pressure to this saturated line na ito ng vapor. Okay, so alalahanin natin na sabi niya rito, during the adiabatic saturation process, babasahin natin kasi nandyan yung substance. During the adiabatic what? During the adiabatic saturation process, the partial yeah, vapor increases. So ito, nag-increase to. Alin, itong line na to, mag-increase to. Diba, paliwanag ko na yan before. Hanggang dito sa point na yan, sa line na yan. So although sabi niya, increases, the total pressure of the air vapor mix remains constant. Remains constant. The unsaturated air initially at dry bulb temperature, ayun, dry bulb temperature, ito dry bulb temperature yan, is cooled adiabatically. Bumaba nga kasi ito papunta rito. Nung siya ay okay. The unsaturated air initially at dry, okay, and cool adiabatically to dry bulb temperature 2. Ito na siya. Which is equal to the adiabatic saturation temperature, TW. It may be noted that the adiabatic saturation temperature is taken equal to wet bulb for all practical purposes. So, meron ka ngayong balance of enthalpies. Ito yung importante, no? Of air inlet and outlet. Ang tawag natin dyan, energy balance. So, ano yung pumapasok dyan? So, yung enthalpy at 1. Okay. At saka yung difference ng moisture mo, W2 minus W1 times itong enthalpy na to, yung sensible heat of water at adiabatic saturation temperature. Ito yung H2 mo. Remember, may H2 ka dyan dito. May enthalpy ka dyan, H2, specific enthalpy. Yan yung formula. Or, pwede rin ganito. H1 minus W1 times HFW is equal to H2 minus W2 times HFW, yung sensible heat of water at adiabatic saturation temperature. Okay? So, energy balance lang yan, yung pumapasok doon sa mo kanina, doon sa dito. Diba? Yung energy in is equal to energy out. Napaka-simpleng equation yan. Okay, so tuloy lang natin. Yan, dito tayo ngayon. Yan. Okay, so itong term na to, let's continue. Yung term na yon, ito, yung H2 minus W2 times enthalpy if W is known as the sigma heat and remains constant during the adiabatic process. So, remain constant yan. Yun yung paalala sa atin. Okay. So, we know that yung H1 is equal to enthalpy plus yung moisture content times yung enthalpy na yan. Okay, same way doon sa exit. No? Okay, H2 is equal to H2A plus W2 times H mod point 2 yun doon sa exit. So ngayon, by equation, we are able to derive ito. Now, the equation 2 may be written yung equation kanina. Okay, yung equation kanina. Sorry. Yung equation kanina. Yan. Ito. Ay maaaring isulat sa ganong equation. Ito na siya. Okay? Yan. Paano nakuha yan? Ito. Balansin mo lang to and then do the simplification. You come up with this. Okay? So, ang final na equation, ito na. W1 is equal to W2 times difference nitong enthalpy mo na ito plus itong enthalpy mo, difference nila over itong enthalpy na to minus enthalpy niya. So, it's all in enthalpies and moisture content pag-exit. So, napaka-importante niyan, no? Okay, dyan naman tayo ngayon. Thanks.